So now let's look at type comparison. And the first bit of this page we looked at already. So here's a table that shows whether particular values are empty, null, set, and then the Boolean value when you convert them to a Boolean. So for example, empty string is empty, but it's not null. It is set, and it converts to Boolean false. Whereas null is empty, null isn't considered set, but also converts to Boolean false. So you might want to review this table. In particular, make sure you understand why 0 is considered empty, but not null. And then we get to loose comparisons. So these are comparisons where the values supposedly are equal, but the types may not be. And this table is really complicated, and there's a lot of gotchas in here. As I said in the previous video, the rules here were chosen so that mostly it does what you would expect and want it to do, but not always. There's some really weird cases in here. So let's actually look at some of the weird cases. So the obvious ones, like true. So true matches true, true doesn't match false. That's what you would expect. When you compare a numeric value to true, basically 0 is considered false, and everything that isn't 0 is considered true. So 1 matches true as true because 1 is not 0. 0 matches true as false because 0 is 0. Minus 1 matches true because minus 1 is not 0. So same thing for the comparison to false. 0 is going to match false. Anything that's not a 0 but is a number is not going to match false. So when you have a string that holds a numeric value, first the string is converted into a number, then the number is converted into a Boolean. So the string double quote 0 double quote gets converted to the number 0, which gets converted to false, and then false matches false and doesn't match true. The string double quote 1 double quote gets converted to the number 1, then the number 1 gets converted to the Boolean value true, and true is equal to true but not equal to false. Same thing with minus 1. It's not 0, so it's Boolean true and it matches true. Null is mostly straightforward. Basically, if a value is an empty value, for the most part, it's going to match null. So true is not empty, and so it's not null. False is empty, and that works for most of these. So 1 is not empty, 0 is empty, minus 1 is not empty, the quoted string 1 is not empty, and then we got this one. So this is the one exception here. The number 0 is considered true, and so this sort of breaks the rule that we were looking at. The rest of them sort of work, but so that one's odd and can sometimes cause problems. Also, take a look at what's going on with these string values here, PHP. So PHP, if I converted this to a number, I'd get the number 0 back. So you would expect that 0 is going to match false and not match true. But we see that PHP actually matches true and doesn't match false. So basically, it's treating it differently if the contents of the string are numeric than if the contents of the string are not numeric. Here, an empty string is false, and it also matches null, and it also matches the number 0, but it doesn't match true, and it doesn't match the double quoted string 0, and so on. So basically, if you're comparing two strings and neither string has a numeric value in it, it compares them as pieces of text. But if either one of the strings or both of the strings is holding a number, It converts them to numbers first, and then compares them as numbers. So, once again, it's easy to make a mistake here. And it also leads to some sort of unusual situations. So for example, let's look at this. So I'm going to echo 0 equal null. And then I'm going to use a ternary operator here to say 0 equal null question mark. True if that's true, and false otherwise. And then I'm going to add a break in here. And then we're going to compare the double-quoted string 0 to null. And last but not least, we're going to compare the number 0 to the string 0. So I'm going to go ahead and load that. And we see that 0 matches null. So that's true. The double-quoted string 0 does not match null because it's not an empty string, so I get false. But the number 0 matches the string double-quote 0 double-quote. So this is true. So we have this is equal to that, and this is equal to that, but these two things aren't equal to each other. Sort of mind-blowing. I get similar situations with comparing strings that hold numeric values, like 3, with other strings that hold numeric values. And let's just go ahead and copy that whole thing. And I'm going to change this to the string 3 and change this to the string 3.0. So in this case, I'm comparing two strings that hold numeric values. So they're both going to get converted to numbers. This will be the integer 3, and this will be the float 3.0. But then the value of 3 is equal to the value 3.0. So this is actually going to return true. Whereas if I go ahead and change the contents of the string slightly, now 3x is not a number and 3.0x is not a number. So now these two values aren't going to be equal anymore. So we expect to see false. So the double-quoted string 3 is equal to the double-quoted string 3.0. That's true. But the double-quoted string 3x is not equal to the double-quoted string 3.0x. That's false. So the bottom line is, as I said before, it's really easy to make a mistake here. It's really easy to get logic that you think does one thing, but it actually does something else. And the net result is that most programmers try to avoid loose comparisons whenever possible. They try to only use either type comparison, Strutt comparison using equal, or they do explicit typecasting themselves before they do the comparison. And that's mainly to avoid all of these weird cases. Now let's look at the Strutt comparison. So here both the value and the type have to match in order for this to be true. And look how easy this table is, basically. You have trues through the whole diagonal and false everywhere else. So this one's really easy to understand and really easy to use, whereas this one, kind of a mess. So bottom line, I urge you to do your own typecasting and use Strutt comparison whenever possible.